Now, we're just going to open it to questions. Hopefully the questions will create more questions and so on. This is a small group, so everybody ought to have their personal questions, everything they can think of answered.
I'll try to break the ice here if I can make the microphone work.
Yes. Good. Get it on green. Make sure it's working.
As I understand it, the experiments you're going to conduct they're of course in this reality, and are they going to be variants of the double slit experiment, or are they completely new genre?
They're variants of the double slit experiment, but they're variants that have never been done before.
Right. So you haven't done them either, or you haven't tinkered with them either.
No. I've just come from theory,
Right.
from MBT theory, and how to apply MBT theory to quantum mechanics. And quantum mechanics now, as a science, has no idea why things work the way they do. Matter of fact, you'll hear physicists who should know better saying things like, the particle somehow goes through both slits at the same time and interferes with itself. And that's not the writers trying to make it accessible to the public. These are the actual physicists trying to describe what's going on. And of course, that's silly. The particle doesn't break in half and then go through both and interfere with itself. That's not the way the world works. But they really don't have any idea how it works that way. All they know is how to do the math to get the right answer so that they can predict what the result's going to be. And the math basically looks at the particles as probability distributions. And then they do their math, which basically integrates the probability over all sorts of places, and then they make a measurement. There's a lot of holes in that, philosophically, logically. There's a lot of holes in doing that. How is it when they make a measurement that they get a particle there at that time? It's just probability. Well, they don't know about that. They just know that the math will work if you consider the particles to be probability distributions.
Shut up and do the math.
Shut up and calculate, yes. Famous quote, Richard Feynman, shut up and calculate. So coming to this from a theoretical viewpoint, where you have a theory, and particularly a theory of consciousness, and then you apply that theory to quantum mechanics and come up with the results of the experiments. In other words, you can predict what the results of the experiments would be, and the predictions are correct. That means you actually understand it, and you understand why, and you have some way it makes it a rational science rather than just a computational science. So that's the thing. Now, these experiments that I have, the first one, which is I think they will get done this month, is one just to test the basic theory of how virtual reality applies to this double slit experiment. And that's one where you have all of quantum theory on one side that says, no, that won't work this way, it works another way. And virtual reality says, well, it's a lot simpler if you just, and I think it'll work this way. So it's kind of David and Goliath, me being David and Goliath being all the rest of the quantum science. So we'll see how that comes out. Now, if that one works out the way I say, that should create enough interest in the community because they will see that they're wrong, that it doesn't work the way they think it does, which means that if they're scientists at all, they should have this need to go check it out and see indeed whether or not that's the way it works. In which case, we won't have to pay anybody to do it. They'll be doing it on their own. And hopefully will generate some interest, and all the rest of it will get easier and easier if we get past that point. Now, it's possible that they won't work out the way I think, because in order to apply quantum mechanics to double slit experiment, in order to apply virtual reality to quantum mechanics, I should say it that way, I have to make a few assumptions. And one of the major assumptions is that the larger conscious system will compute it in the most efficient way. In other words, good computer science. It will compute in a way that a good computer science would write the code. It won't be sloppy code. It'll be good code. So that's one assumption. Now, that assumption, of course, hinges on whether or not I know what the most efficient way that it could be written. You see, so that's what I think, that this is the most efficient way. So I think this is the way it'll work. But there could be something else that I'm missing. Or it could be that the system decides for other reasons that, in this case, it won't necessarily do it the most efficient way. It'll do it some other way just because it has some other issue that it wants to dealing with. You don't always code in the most efficient way, depending on whether there's something else that makes you want to do this in a less efficient way because it makes something else better for you. So these are assumptions that I have to make. So it's possible that it's not going to work out right, but I think it does. Usually, the most simple, direct way is the way things work. In my experience, that's like 99% of the time, things work that way. The system's been around a long time. It's been able to optimize its code and optimize the way it does things pretty well. So that's been my experience, that it is efficient and effective in its processes. So I think it'll probably work the way I say, but I don't know. That's why we have to do the experiment. I come from a place of theory. Fact is defined by experiment, not by theory. So we'll see. So if it doesn't work out the way I say, then that means I need to go back and relook at assumptions and see if I can't come up with some other way. It doesn't really call into question any of the theory about consciousness. It's just how I apply that theory to explain quantum mechanics would be the part that is affected by it, which I would have to change. Now that's just a simple experiment that I have that I think will be done, which is kind of one of the most crucial ones. Then I have a couple others that are interesting that will demonstrate with a fair amount of credibility that, one, the reality is virtual, and that consciousness is the computer. Both of those. And it'll demonstrate that in a little more dramatic way than just the double slit in itself. The problem with the double slit is that, yes, it does something that's impossible. It takes particles who seem to, for no particular reason, arrange themselves in a diffraction pattern when they should just pile up behind the slits. Okay, so we don't measure what slit the particle goes through, and they rearrange themselves in a diffraction pattern, which is impossible because even Newton told us that particles travel in a straight line unless acted on by some external force. There are no external forces, yet these particles arrange themselves. They don't travel in straight lines. They travel in ways that they end up with a diffraction pattern. So that's impossible, but it happens anyway. So that's kind of the miracle of the double slit experiment. By miracle, I mean something happens that shouldn't. There's no explanation for. But with the double slit experiment, you're talking about very small things that nobody can see. You're talking about detection apparatus that's very, very sensitive, that has to detect without disturbing what it's detecting. Very difficult to do. So you have these places where questions can creep up. Well, maybe it's something about the detection process, which is the way science has gone. Oh yeah, in the detection process, there's entanglement between the particle and the detector, and that's what's driving things. And that's the position that quantum physics has taken, and I say nonsense to that, so we'll see. But anyway, there's this these fuzzy areas that have questions in them that make the experiment not quite so dramatic. The ones that I plan to do will be more dramatic in that. There will be a physical thing, not something that you can't see, but a physical thing that you can put your hands on that will, perform another miracle. It will act in such a way that's impossible. That's a little more dramatic because it's not small particles and it's not, detections and so on. It's just this big chunk of glass, and particles come to this glass. It's called a beam splitter, and it's made in such a way that 50% of the time the light will go through it, 50% of the time it'll be reflected. In your mind, you can think of that as a piece of glass that has a bunch of tiny little mirrors in it. And the area of the glass, 50% of that area is covered by these little mirrors, and between the mirrors, it's clear. So just depending on where it hits, it gets reflected or it transmits. Okay. That's not the way they're made. It's not a piece of glass with a lot of mirrors in it, but that's just a model, a way of thinking about how it works. So to be able to predict whether it's going to transmit or reflect, you're predicting how this chunk of glass is going to interact with reality, which is impossible. And there's no questions. There's no fuzzy areas about it. It's just perfectly clear. And the other experiment is you take a radioactive source, and a radioactive source spits out particles. That's what radioactive sources do. They're radioactive because the atoms will go from a higher energy to a lower energy state, and when they do that, there's energy left over, and they spit out a particle. It's called radiation, right? So radioactive sources radiate particles, and these particles go out in a random direction. There's no way of knowing what direction the radiation particle will come out. So in my experiment, I put a hemisphere on either side with the radioactive particle in the middle, with a hemisphere detectors on either side. So when that particle comes out, it's going to hit one hemisphere or the other hemisphere. Okay, that gives us a binary, like a 1 and a 0 or a yes, no. Okay, and my experiment is set up so that I will be able to predict which of these hemispheres the particle is going to hit. So that's predicting the direction of a naturally random process, which means you don't really have a physical atom. It means it has to be calculated. There's no other way that you can predict that happening other than the fact that your experiment sets up conditions that calls for one having to happen or the other having to happen, and that is controlled by the machine that's rendering the reality, which requires consciousness. It requires an aware machine, because you change your experiment and it changes how it reacts to it. So we have physical reality modifying itself based on the choices that we make, which says that consciousness is involved somehow. Awareness is, the system is aware of what we're doing and modifies itself accordingly, you see. And it's completely impossible that one could do that. After all, it's just a physical atom and it's shooting out particles, and there's absolutely no way to control that. So that can only happen in a virtual reality, and only in a virtual reality that is aware and interactive. Not just a machine that just does stuff because it's this big machine, and all it does is, react, which is the way science thinks about things now. So those are the experiments, and I hope they all work out that way, but we'll see. I'm excited to see. Whichever way it goes is okay with me, in the sense that I'm going to learn something. That's why you do experiments, to find what the truth is. And then that truth will help you refine your model, or it'll verify your model, or it will tell you that your model isn't right, which is how science progresses. Now, typically in physics, getting to a major breakthrough takes lots of experiments. You know, you experiment and it doesn't quite work, but it gives you a hint, and then you do another one to follow that hint, and that gives you another hint. And typically after a series of experiments, you end up with an aha, because you've narrowed down what's going on and you've figured something out. That's typical. Okay. I'm hoping to get it on the first try, which is not typical, but this is kind of simple theory, so we'll see if it works. So that's kind of all about the experiments and why they're significant.